In this video, I'm going to show you 2 ways to make epoxides. Let's jump right in. So epoxides are these 3-member ether rings that are triangles, but they're carbon, oxygen, carbon. So this is an epoxide. So there's 2 ways we can make these types of epoxides. The first one is from an alkene. We can take an alkene. We need to give it something with an oxygen atom. And one of the best ones to use is mCPBA, and carbon tetrachloride is my solvent. And it can make epoxides. Now this sort of compound is called a peroxy acid. So you might remember that this is a carboxylic acid. This looks like a carboxylic acid with an extra oxygen right here. So this is a peroxy acid. And these want to give away one of the oxygen atoms, so it can become that carboxylic acid. And it'll give away one of those oxygens to an alkene, to the double bond. So mCPBA is this particular peroxy acid. It's a phenyl ring. And a phenyl carboxylic acid is called benzoic acid. This is peroxy benzoic acid. And mCPBA means it's meta at the ortho meta position to this group. It's a meta-chloro peroxy benzoic acid. And I just show you this to show that it's got the extra oxygen and it's got a chlorine here, which helps it dissolve in carbon tetrachloride. We want a solvent like this that does not get involved in the reaction and doesn't react with epoxides. If you have water around, other things happen. So you don't want water. So mCPBA, I would just memorize that acronym, and that's how you turn an alkene into a epoxide. That's one way. The second way also goes back to an alkene reaction. And we saw previously that if you react an alkene with Br2, the first step of this reaction, let me draw bromine this way, is the double bond attacks the bromine, that leaving group leaves. The bromine is so big, one carbon can't hold it up, and the other carbon can't hold it up. So it takes both carbons to take up and be able to hold up this bromine to make a bromonium ion. So it takes both carbons and it makes a triangle with a positive charge. You should go back and watch my triangle mechanism reaction videos so you can see the analogy I use with triangles. But if you've watched that, I'll talk like you've watched it. This is a victim that's carrying money above its head. So it's carrying more money in this pocket because these are the bags that it's carrying. If that doesn't make sense, go back and watch that other video I'll link to. When I only have Br2 in the reaction, this bromide would backside attack. The electrons will go up to that bromine to make this bromine compound, dibromide. And that happens if I run this with Br2 in some solvent that does not get involved. But if instead of carbon tetrachloride, I have water in there, the mechanism would be this. The alkene attacks the bromine. This bromine leaves. It's so big it's going to be held up by both of those as a bromonium. And this carbon has 2 carbons on it. And we still have Br minus that would want to backside attack. But if we use water as the solvent, There are gazillions of waters in this beaker and very few Br minuses, bromides. So instead of the Br minus attacking, the water will backside attack. Electrons go up to the bromine. So the left carbon has the bromine on it. The right carbon has the water on it. So I'll have a positive oxygen, and there's still 2 carbon atoms on this one. Another water molecule would clean that up to make this. This is called a bromohydrin. Now, once you have a bromohydrin, how that can make an epoxide is if I can make this oxygen an oxide, an O-, then the magic will happen. So how do I make this an O-? Well, I need to pull off this H+. So we need a very good base. So the base might be something like sodium or some kind of sodium hydroxide. I'll pull off that proton. Those electrons stay on the oxygen. And once I make a negative oxide, this aggressive nucleophile can backside attack the carbon right next door because it has a great leaving group on it. And I can make my epoxide. So that's the second way we can make epoxides. Use bromine, but make sure water's my solvent. So when I brominate and make a bromonium, the water backside attacks. When I clean it up, I make a bromohydrin, an alcohol bromine on neighboring carbons. Pull off the proton, make O-, and that can backside attack to make my epoxide. I hope that helps. Subscribe to my channel and watch more of my organic chemistry videos.